Hi, Algebra 2. In this video, we are going to be working on dividing polynomials. Here we go. The first method we're going to use to divide polynomials is long division. So think back to how you've done long division before with just plain old numbers. It's going to be the same process for polynomials. So to divide this using long division, I set it up with my long division symbol. And I have to start thinking x times what gets me x squared. And I know that x times x gets us x squared. So then we multiply this x times x and we multiply it by -3. So x times x is x squared. X times -3 is -3x. And then just like in regular division, we're going to subtract everything. And so x squared minus x squared is nothing. And 5x minus a -3x is going to be 8x. And then we bring down what's left. And now I have to decide x times what gets us 8x. And that's going to be 8, so I have plus 8 up there. And I multiply everything out. 8 times x is going to be 8x. And 8 times -3 is going to be -24. Just like before, we subtract everything. Sometimes I like to put parentheses there to remind me that we're subtracting everything, because sometimes it's easy to miss this negative. So 8x minus 8x is nothing. -28 minus a -24, that would be just like adding, so I'm at -4. So now this is my remainder. So up here I'm going to write that as -4 over -3. So then this whole thing up here is your final answer. One thing we need to watch for when we are setting up our long division is that our exponents are really in order. So we start with the largest exponent in the term and then we go down from there. And then as you set up your long division, if there's a term with an exponent that you're missing, for example, we have a y to the third, we have a y squared, but we don't have any just y's, we need to include that in our division. Otherwise, it's really going to mess up your answer. So I'm going to write 0y right there. Okay, so now I have 2y squared up here because 2y squared times y is going to be 2y to the third. And then I'm going to take that times -3 and I'll get -6y squared. I'm going to subtract all of that. And so I have no more y to the thirds. Here I have -y squared minus a negative. So that's just like adding 6y. So that would be 5y squared. Everything else we bring down. And now we are going to do plus 5y up here because that times y is going to get me 5y squared. And 5y times -3 is going to be -15y. And again, we subtract everything, use my parentheses to remind myself. Here I'm going to have a positive 15y plus 25. So now up here we have plus 15 because 15 times y is going to get us 15y. And then 15 times -3 is going to be -45. Subtract all of that. I end up with a positive 70 down here. And so that is my remainder. I'll mark it with an R. And so up here, I'm going to add that onto the end as 70 over y minus 3, whatever I was dividing by. We can do different things with the remainder, but for right now, we're just going to add it onto our answer like that. Okay, here's what I have so far. Check your work with what we've done. And now I'm wondering 3x times what gets me 3x? And that's going to be plus 1. So then 1 times 3x will be 3x. 1 times 1 will be 1. I subtract off all of this. I'm going to end up with just -13 at the end. So up on the top will be minus 13 over 3x plus 1. And that'll be my answer. So that was long division. Now we're going to look at synthetic division, which is a little bit quicker method. It is useful only when your divisor is x minus or plus something. So keep that in mind. If there is a coefficient in front of x, then synthetic division does not work. This is how your book shows you the steps for synthetic division, so use that to refer to if you need, but we're going to work out some examples to show you how it goes. First thing in synthetic division, we need to figure out what A is, or what number we're going to put in this box right here. A is really going to be the 0 of this factor right there. And so in this case, A is going to equal 6, because if x is 6, then that factor equals 0. 6 minus 6 would be 0. So I'm going to put that in the box. The next thing we do is we write down the coefficients from our equation. So there's a 1 here in front of x squared, so I have 1. Negative 3 in front of x, so I have negative 3, and then negative 18 down here. These do have to be in order of greatest exponent to least. And I leave a little space down here and draw my line. First step is to just bring down your first number. So I'll just bring down 1. Now I multiply. 6 times 1 is 6, so that goes here. Then I just add those together, and so I'm going to have a positive 3. Next step is 6 times 3, multiply again, that's going to be 18, so that goes right there. Add those together, I get 0. This last number goes in a box because this is the remainder. And so my answer, I'm going to use these to write my answer, and I write them just starting at the end with just 3, and then the next term will have the x in it, so this would be 1x plus 3, or just x plus 3. There is no remainder here, so I can just leave it as x plus 3. Okay, I've set up this next problem. My a value is negative 2, because if x is negative 2, then this whole piece equals 0. Then I've put in all my coefficients, so there's my 3, here's my negative 1. Remember, these are in order. I don't have any x squareds, so I need to put a 0 there. Make sure that that happens if you're missing a term, because otherwise it'll totally mess up your division. Then we have 5 for just x, and then we have our negative 1. First step, bring down the 3, and now we multiply. Negative 2 times 3 is negative 6, so that goes there. We add those together, that's negative 7. Then we just multiply again. Negative 2 times negative 7 will be positive 14. Add and bring those down. Negative 2 times 14 will be negative 28. Again, we add and bring this down. And negative 2 times negative 3 is going to be a positive 46. And we add and bring that down. So this is my remainder. So to write my answer, I'll have negative 23 plus 14x plus negative 7x squared. I need to make the exponent 1 bigger, plus 3x to the third. So again, notice that those exponents just keep getting bigger as you add more of those numbers on. And then the remainder at the end, just like before, we'll add that on as a fraction. So it'll be 45 over that original divisor of x plus 2. So there's your full answer. Okay, when I did synthetic division here, brought down the 3, 1/3 times 3 is 1, added, 1/3 times 10 is 3 and 1/3, added. So this is my remainder. So my answer is going to be 10 plus 3x plus, it's this 1 and 1/3 over x minus 1/3, that original divisor. So that looks really weird on the end with all those fractions right there, but that's okay. That's how it is. Synthetic division is not just faster, it can actually help us evaluate polynomials when they're kind of long and maybe cumbersome to deal with all of those numbers. How this works is called the remainder theorem, and this is the definition and example that's in your book. So let's go work through a few. We're going to use synthetic division to evaluate this polynomial if x equals 2. And so I'm going to put 2 in the box and write down all of my coefficients, and we will do the synthetic division. And if what I'm doing here isn't making sense, go back and review the previous few slides. So when I'm done, I end up with this remainder of 41. And so what that means is that p of 2, meaning I plugged in 2 to the function, it ends up equaling 41. If I put in 2 for x here, 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 and evaluated it, I would get 41. Okay, as I worked through the synthetic division on this one, you can follow my work here, and we end up with a remainder of 7. So that means that p of negative 1/3, if I plugged in negative 1/3 for x in all of that, the function would equal 7. And doing the synthetic division like this might even be faster than plugging that negative 1/3 into a calculator. Okay, here's the work for this one, and I end up with a remainder of 4. So what that means is that p of negative 3 equals 4. It's helpful in this one to draw a picture of what's going on. The area of the rectangle is this, the width is y minus 9, and I'm remembering that area equals length times width. So if I know this and this, I can divide them to get the length. I use synthetic division. I think it's a little bit quicker and easier. And when I do that, I end up with this on my last row. There is no remainder. And so I just need to write my answer as negative 5. And my variable was y, so that's just going to be 1y. So y minus 5 is going to be the length of the rectangle.